Okay, let's see how you did with this and determine where you got stuck. If you just have the symbol SE, is that an atom or an ion? If you have the symbol Fe2 positive or Fe3 positive, that is an ion. If you have the symbol S2 negative, that is an ion as well. If you have just the S, that is an atom. So a neutral atom does not have any positive or negative integer sign as an exponent. Next question, number 2. If something has 20 protons and 18 electrons, is that going to give you a neutral or a zero answer?
No.
No. So that is a no. If something has 3 protons and 3 electrons, that is an atom. Atoms, by definition, are electrically neutral. That means they have to have the same number of protons and the same number of electrons. 15 protons, 15 electrons, that is an atom. Finally, 8 protons and 10 electrons, that is an ion. Any questions so far? Oh, and 6 protons and 6 electrons is an atom. Number 3 is going to get a little bit more challenging. I have 20 protons, which will have a positive charge, 18 electrons. Is the substance going to have a positive charge?
Yeah.
Or a negative charge?
Yeah.
Definitely a positive charge because there's fewer electrons compared to the number of protons. If I have positive 3 and 2 electrons, is that going to be a positively charged ion or a negatively charged ion? Okay, that's going to be a positive charge as well. In order for something to have a negative charge, it needs to have more electrons than protons. So the third is a negative ion or an anion. This one, positive 8, negative 10. That's a negative charge. Absolutely. Protons, positive 6. Electrons, negative 2. Is that going to be a positive or negative charge?
Positive.
Whenever there's fewer electrons than protons, that's going to be a positive charge. If there's more electrons than protons, that's going to assume a negative charge. How are you going to come up with the identity of the substance? Absolutely. Are you going to use the number of protons, or are you going to use the number of electrons to look at?
Protons.
Absolutely the number of protons. So first job is to find out what number 23 is.
Vanadium.
Vanadium. Symbol is V. We have 23 protons and 23 electrons. It's neutral. This substance will only be V. Interestingly, the next one also has the symbol V. However, it has 23 protons, 18 electrons. What charge is this going to have?
Positive.
Positive. Please make sure that when you write charges in chemistry, you write the number and then you write the positive or negative sign.
So otherwise it's oxidation metal.
Absolutely. Oxidation metals are going to tell you something a little bit different, and they're used differently as well. We can actually use them as a strategy to balance chemical equations. the third one down with 20 protons and 20 electrons. What is that going to be?
Water on.
20 protons. Remember, look at the number of protons is the atomic number. It's number 20 here. The symbol for that is Ca. Do you have the same number of protons and electrons?
Yeah.
Absolutely, which means your symbol is simply Ca. The next substance has 17 protons and 18 electrons. What is this substance?
Negative.
It is? But what is the symbol?
Oh, Cl.
Cl, 1 negative, or you can just put Cl negative. Because we're writing the negative sign, we're already indicating that there's one negative charge. But if life is not complete without writing number 1 and then negative. The next substance has 4 protons and 2 electrons.
Beryllium.
Beryllium.
Ye.
If we only say beryllium, we are indicating that substance is an atom. We have to add the word ion, and for some of them, we even have a name change. So today, our goal is this. We are going to practice writing ions, and then combine ions to form simple binary ionic compounds. You will leave your notes that you received last grade, and you can continue filling that in. We left off on the page where there is a sodium atom drawn here for electrons. In this case, we have sodium giving up one electron. It's going through oxidation. Sodium loses one electron pretty easily. Because it does that, it can assume a 1 positive charge and form the sodium ion, sometimes known as the sodium cation. Remember that the word cation here refers to something that has a positive charge. So we come back to this one where we left off yesterday. Does this make sense now? You lose an electron, you have a positive charge. You know, you're starting to understand this Patterson's sense of humor. Oh. Okay, let's talk about the chlorine atom. Chlorine is a bully. Chlorine loves to steal electrons from other things and complete its last shell in the Bohr atom. So nonmetals, which are on this side of the table, the right-hand side, form anions when they gain electrons. This process is called reduction. The chlorine atom starts off with 17 positive charges and 17 negative charges. If one more electron is added to that, we have 18 electrons now. For some reason, they decided that nonmetals would have to change their name to become an ion. So instead of saying the chlorine ion, we say it is a chloride ion. Snap an IE ending up here. When we write out the symbol, it still starts with Cl. But because we've gained 1 electron here, that chloride ion is going to have a 1 negative charge overall. 2, 8, and 7. is your electron count. And chloride ion model is going to be 288. Oxidation and reduction always work hand in hand. If I have an electron to lose, I can't just go, whoa, and lose the electron. If I lose the electron, something else has to take that electron. That's how we get an ionic compound formed.
By 9:30.
Oh, there it is.
I gotta go to bed.
Okay. So some key points for you to remember from this first introduction here. The first one is making sure that we know what the difference is between atoms and ions. Atoms do not have an overall electrical charge. Ions do. Ions have a charge because the number of electrons has changed. If the substance has gained electrons, then it will be a negative ion. If something has lost electrons, then it will be a positive ion. The reason why something gains or loses electrons has something to do with those orbits. It is highly desirable to have field energy orbitals. Do you remember talking about Bohr models once upon a time? Okay, I'll give you a chance to write this down. And Niels Bohr stated that an atom looked like a solar system model. The sun of the solar system model is the nucleus of the atom. The planetary orbits of the sun represent where you would find electrons. And you would find electrons based on how much energy they have. More energetic electrons are going to be found further away. Versus lower state, or what we call ground state electrons, will be closer. Because if something's moving slower or less excited, a positive nucleus will pull those electrons in. That's why this is attract. Things want to have. Oh, I threw my pen away. Things want to have field energy levels. So hydrogen, which is really unique, only has one electron in this outer energy level. So there's two choices. You can give up that one and only hydrogen ion and forms H positive, or it will take an electron and fill that place over there, making H negative. The hydrogen ion. If you have something like lithium, which has 3 electrons, do you think lithium would be likely to lose that one electron?
Yes.
Or do you think lithium is going to gain 7? Fine.
Because it eliminates a ring and it's closer to filling up the other one, opposed to filling up this one.
Absolutely. It's all about what is the least energetically demanding ring. It is far easier to lose one electron than to try to steal 7 electrons from something else. So all the way up until about 3 electrons, they'll give up. Once they get to 4, they'll share. Once they get to 5 other electrons, they'll start grabbing from others. So this is what we call the Bohr model, and it helps us understand rule number 2, which is atoms will gain or lose electrons, become more stable. And when they do that, the number of electrons is not going to be equal to the number of protons anymore. Third, all the non-metal endings have to change to IGE when they become an ion. Do you remember your names?
For what?
Do you see all your names last year?
My name is Jesse.
For example, oxygen becomes
Oxide.
oxide. Phosphorus would become
Phosphide.
sulfide. What about selenium?
Selenium down.
Shillelagh.
Selenium beyond.
Selenite. What about chlorine?
Chloride.
Chloride. Tellurium.
What was
Telluride. Arsenic.
that?
Arsenide.
Arnide.
Sulfur.
Sulfide.
Sulfide. Okay, so you know some of the common ones that we use quite often. Good. The ion charge is calculated. And we call this the net ion charge. When you calculate, you are adding the integers together. You're adding the positive number, which represents the number of protons, and the negative number, which represents the number of electrons. Remember that when you're adding electrons, that they contribute a negative charge. It's one of the most common mistakes for chemistry students. You can also look up the symbol on the periodic table that you have. On that goldenrod piece of paper, the ion charge is listed in the top left-hand corner. All right. Our next activity is going to be determining symbols, determining names, number of protons, and number of electrons. The first question is N3 negative. Where did we start off with that? N3 negative. Let's see, what's nitrogen 5? Is nitrogen a non-metal or a metal?
Non.
It's a non-metal. Does it have an ion charge beside its symbol?
Yeah.
Means it's an ion and you have a name change. So rather than writing nitrogen, the name should be nitride.
You did correct. It's nitric acid.
If it has the symbol N3 negative, what I would suggest you do is look at the number of protons first, because the number of protons never changes. Take a look at your periodic table.
What?
How many protons does nitrogen have?
3. 10. 6.
Nitrogen has 7 protons. That is a subatomic number. The number of protons always equals the atomic number. We can never change the number of protons something has. Changes electrons, changes neutrons. Next question.
How many electrons is it?
Does nitride have 4 electrons, or does it have 10 electrons?
10 electrons.
It needs to be a negative.
Am I wrong?
It needs to be a negative.
That's that.
Yes.
Yeah.
Remember that this is 3 negative. that means that I have to have 3 more negative charges in order to have a 3 negative net charge. One way for me to check, positive 7 plus negative 10 is negative 3. The next ion U is the zinc.
We can't find it.
Sure you can.
Oh, it's Z, right? The zinc is 30.
Zinc is not a hard one to find. It's number 30.
It would just be Zn, right?
Pardon me?
It would be just Zn, right?
Sure.
So last
Final
one.
answer. Look at the header of your column. What does it say?
Ion name?
Ooh. So it's zinc ion, which means it's Zn2 positive. If it said atom name, then it would just be Zn. Zinc is number 30 on the periodic table, which means it has 30 protons. Does that mean I'm going to have 28 electrons?
Yes.
Or 32 electrons?
28. 28.
Oh, which are you sure about?
Is there such
I said 28.
Oh, sorry. I thought you said 32. The correct answer is 28. A good way to double check. Positive 30 plus negative 28 is equal to positive. Give the rest a try. Here are the answers to the questions. Silver is another element that uses its Latin name as the source of its symbol, Ag positive. It is an ion, so that means it has 47 protons and 46 electrons. Oxide, because oxygen is a nonmetal. O2 negative, 8 protons and 10 electrons. Magnesium, Mg2 positive, 12 protons and 10 electrons. We have the last 4. Did I catch anybody on these ones? Or did you figure out what those Roman numerals meant? Did you talk about them last year? No, you just figured it out? Awesome. So what is your logic for figuring out those Roman numerals?
I don't know.
What's your logic, Kaylee?
Well, because I know, like, that's 2, and I know that's 3.
Exactly. So depending on how much energy there is, some of these transition metals can form more than one ion. I like to call this block, which is the B block, it goes from here all the way over to here. I call them the teenagers of the periodic table because they don't follow the rules. They're rebellious. And because they're a little bit rebellious, they have really, really cool properties. Most of the colors that you see in this room are due to one or more of these elements. If all we had in the rule was the A's over here and the A's over here, we probably wouldn't have color. So, it just goes to show you, teenagers make the world colorful.
We're already back.
So, iron 2 means that you are using the 2 positive charge. Iron Roman number 3 means that you're using the 3 positive charge. Gold 1 means that you're using the 1 positive charge. And gold 3 means that you're using a positive.
So why don't you go silver and then put 1 in the brackets?
Take a look at silver on the periodic table. Up in the right-hand corner, what is the charge for silver?
+1.
Okay, now find gold, which is almost right underneath it. Look in the top right-hand corner. What's the difference between the 2 blocks?
It has 2 different ones. Three clauses.
Silver, if it's gonna form an ion, can only form Ag1 positive. It doesn't have any other ion that it can form. Because of that, there's no Roman numeral. Only time that you use the Roman numeral is if it does form a second ion, and we can keep them strict. Okay. Otherwise, we get confused. It used to be that instead of using Roman numerals, we would use Latin names. So instead of saying copper 1, we would either use Cuprous or Cooper. Depending on if we wanted the larger charge or the smaller charge. That means we have to know what the IC and OUS endings meant. And we also have to know the Latin names, the elements on those periodic tables and on the name them. Classical naming is still used in some places, but it's not as common anymore. Which is kind of a shame because it's using the original Roman names. Whenever you have gain and loss of electrons, you have two things, at least two things working together. Think of a baseball game. If that catcher is going to catch the ball, the pitcher has to throw the ball. The pitcher doesn't throw the ball, there is no ball to catch. In order for something to gain an electron, something has to lose an electron. Oxidation and reduction always goes hand in hand. If we have the sodium ion, which is Na, 1 positive, and the chloride ion, which is 1 negative, the opposite charges attract each other, and they form a bond based on that attraction. This special attraction is called an ionic bond.
Aww.
Who says you can't have chemistry in chemistry? I know, that's bad. So this is a picture of it. It's the same picture that's in your notes. What it's trying to show you in this picture is the electron that is marked with an X here is actually physically moving over to the chlorine side. And because of this, the sodium has a 1 positive charge, the chloride has a 1 negative charge. These are ionic compounds. If you look at the name, what do you notice about the name?
The non-metal change.
So first name, second name, if you ever lose track of what order to name it, look at the periodic table. Where's sodium on the periodic table? It's over here. Where's chlorine on the periodic table?
Right there.
Over here. So when you name it, this comes first because it's on this side of the periodic table. This comes second because it's on the other side.
Oh, another penis.
Non-metal ending names always have to be ID.
Oh my gosh.
Why am I going?
Oh,
Thank you.
why are
Oh my. So proud of her.
You get it so
It's
James
lit.
Bond.
I see one that's lit.
James.
Says, perhaps one of you gentlemen would mind telling me just what is outside the window that you find so attractive.
Oh.
Well, I'm gonna keep this. You do know that since we are in the chemistry unit, it does need a chemistry music videos too.
They don't exist.
Whenever you name an ionic compound, the cation or the metal comes first, then the anion. But always remember to change the anion name to ITE. You have 4 things to name at the bottom of that worksheet. Please name them.